Hello and welcome to the chapter Numbers. Today we are going to discuss the types of numbers. So let's get started. The first and foremost category is the natural numbers. They are positive integers. They start from 1. All the numbers that we use to count objects or number items in the list are called natural numbers. For example, 1, 2, 3, 4, so on and so forth. Even all the numbers such as 10, 100, 1000, 10,000 and all the positive numbers are called natural numbers. Next, we have integers. All whole numbers, be it positive or negative, and inclusive 0 are called integers. They are numbers that we use to measure mathematically or scientifically a few values of quality or quantity such as temperature, elevation, angle, bank balance, etc. Next, we have prime numbers. The prime numbers are greater than 1 that have only two distinct positive divisors, 1 and themselves, which means they can only be divided by either themselves or 1, such as 2, 3, 5, 7, 11, and all those numbers that cannot be divided by any other number to yield an integer output are called prime numbers. They are used in the process of prime factorization that we are going to take a look at in this chapter, and in cryptography. Cryptography is a method of encrypting text over internet so it can be kept safe. Next, we have square numbers. They are the result of multiplying a number by itself, such as 1, 4, 9, 16, so on and so forth. If we look at the examples, we can see that 1 multiplied by itself, 1, gives us the output 1. 2 multiplied by itself gives us the output 4. Similarly, 3 times 3 is 9 and 4 times 4 is 16. So 1, 4, 9, 16 are called the square numbers. They are used to calculate area of squares, perfect squares. Next, we have cube numbers. They are the result of multiplying a number by itself 3 times. Similar to square numbers, where we were multiplying a number by itself only 2 times, now we are doing it 3 times, such as 1 times 1 times 1 yields the output 1, 2 times 2 times 2 is 8, 3 times 3 times 3 is 27. Similarly, 4 cube is 64. They are used to calculate volume of perfect cubes. Next, we have rational numbers. They are numbers that can be expressed as a fraction or in decimal form, but they must be finitely stoppable in writing, such as 1 by 2 or 0.5 or minus 3 by 4. Their counterparts, the irrational numbers, are the ones that cannot be expressed as a single fraction. These numbers does not stop or have finite endpoints when we are writing them. For example, the value of pi is 3.14159 and it continues and it never actually stops. For simplicity, we write the value of pi as 3.142 or 22/7. But the true value of pi cannot completely calculate it. This is why it is an irrational number. Next, we have reciprocals. They are two numbers whose product is 1. In simple words, if we multiply 2 by 1 upon 2, we get the output 1. Similarly, if we had 3 multiplied by 1 over 3, we would get the output 1. This is an example of reciprocal. In this example, 2 and 1 upon 2 are reciprocals to each other. So now let's visualize what we have studied until now. We have studied the real numbers, and inside these real numbers we have two primary categories, the rational numbers and the irrational numbers. Inside the rational numbers we have integers. Integers are positive and negative and zero numbers. And inside the integers, we have whole numbers. Whole numbers are 0, 1, 2, 3, so on and so forth until we reach an infinite amount. Next, we have natural numbers, which are all the whole numbers except for 0. So now let's move ahead to the concept of common factors. Numbers that divide two or more numbers evenly and have an integer remainder are called common factors. For example, 4 and 2 can both be divided by the number 2. 9 and 12 can both be divided by the number 3. 8 and 12 can both be divided by the number 2 and 4. 6 and 12 can both be divided by the number 2, 3 and 6. That makes these numbers the factors. The numbers on the right are the factors, the common factors for the numbers on the left. If, for example, if we look at the third example in 8 and 12 example, for example, if we look at the third example, that is 8 and 12 can both be divided by 2 and 4. It means that they have the common factors 2 and 4. Both of these are their common factors. Similarly, for the last example, 6 and 12 can both be divided by 2, 3 and 6. 2, 3 and 6 are all common factors of 6 and 12. Now let's understand the concept of common multiples. Common multiples are numbers that are multiples of two or more numbers. For example, 8, 12 and 16 are all common multiples of 2 and 4. Moreover, 20 and even further numbers that are multiples of 4 will also be multiples of 2, and this is why 2 and 4 are common factors to these numbers, and then these numbers become the common multiples to the factors. Similarly, in the second example, 6, 12 and 18 are all common multiples of 2, 3 and 6. That makes 2, 3 and 6 common factors to 6, 12 and 18. Multiples and factors are the left and the right hand sides of the equation. Now we come to the concept of what is highest common factor. It is the largest number that divides exactly into two or more numbers. In simple words, it is the highest common factor. We have understood the concept of common factor, and if we were to calculate or find the highest number from these common factors, then that would be our highest common factor. It can be found by prime factorization and division method. Similarly, least common multiple is a term that is used to calculate or find the smallest number that is a multiple of two or more numbers. It can be found by prime factorization and division method. So let's understand what is prime factorization. It is the breaking down of a number into its prime factors. What we mean by prime factors is that when we were understanding the concept of common factors, we realized that these are the numbers that when multiplied with each other gives us the output. So prime factors are basically factors that are prime numbers in themselves. So for example, 6 can be written as 2 times 3, where 3 and 2 are both prime numbers. Similarly, 8 can be written as 2 times 2 times 2, where 2 is the prime number. 12 can be written as 2 times 2 times 3, because 2 times 2 is 4 and 4 times 3 is 12, but we cannot write 4 because 4 is not a prime number. So we divide the prime number into its common factors that are prime numbers. Similarly, for 36 we get 2 times 2 times 3 times 3, and for 72 we get 2 times 2 times 2 times 3 times 3. 3 times 3 is 9. 2 times 2 times 2 is 8. 8 times 9 is 72. To calculate highest common factor by prime factorization, we have to find the common prime factors. For example, if we are calculating the HCF of 12 and 18, we write them in their prime factors, and then we find the common numbers that appear in both the prime factors. In this case, we have 2 and 3. Notice that this 2 and the 3 in the center are not common in both the cases. So our highest common factor becomes 2 times 3. These are the common values, common factors in both the numbers. So our highest common factor for 12 and 18 becomes 6. Let's look at another example. If we are to find the highest common factor of 15 and 24, first we have to write the prime factors. So we write them in their prime factorized form. That is, for 15 it is 3 multiplied by 5. For 24 it is 2 times 2 times 2 times 3. 2 times 2 times 2 is 8 and 8 times 3 is 24. So this equation is correct. Now we have to find the common prime numbers. So the only two common values in this case are 3. So our highest common factor becomes 3. Now let's look at how to calculate least common multiple with the help of prime factorization. If we were to calculate the least common multiple of 12 and 18, we would start by writing them in their prime factor form. So for 12 we get 2 times 2 times 3, and for 18 we get 2 times 3 times 3. First we find the common values. This is similar to finding the highest common factor, but we are also going to take into consideration the uncommon factors, which are 2 and 3 in the center in this case. So what we do is we simply write the first two values that are the common factors, and then we write the uncommon factors. So we multiply them both, and then we get the final least common multiple. In this case it is 36. In the final example, let's have a look at a little bit of counting. Now there are different words that are used to explain how many zeros or how much zeros we mean. So if we are saying that we have 100 or 200 of some item, we are basically saying we have 2 zeros at the end of our counting. If we are saying 1000, we have 3 zeros. If we are saying 100,000, we have 5 zeros. In between these, we have tens of thousands, such as 10,000, 20,000, 30,000. In this case, we might have four number of zeros. For millions, we have 6 zeros. For billions, we have 9 zeros. In simple words, when we are counting, we write them in pairs of 3. If you notice that after 3 digits from the right, we have a comma. This helps us count or remember the correct word. If we have a 1 comma, then we are at either 1,000 or 10,000 or 100,000. If we have 2 commas, then it means we are at a million, and then tens of millions, and then hundreds of millions. For 7 and 8 number of zeros respectively, and for billions we have 9 number of zeros. Remember that for after 3 zeros we put 1 comma each. This helps us remember at what level of the word we are standing in our counting. That's it for this video. Thank you for watching. Goodbye.